Welcome to the deep dive.
Scalability, it's the big hurdle blockchains are always trying to clear, isn't it?
It really is the Everest, as you put it.
Yeah, we've got these potentially world-changing systems, but when you're looking at transaction speeds, well, Bitcoin was doing maybe 4 per second
Right.
back in late 2021.
Right. And early Ethereum, maybe around 30, which sounds better, but still nowhere near what you need for global adoption.
Exactly. It's
Oh,
like rush hour traffic trying to squeeze through a tiny lane. You get network jams, you get high fees, sometimes fees that cost more than the thing you're trying to send.
absolutely. It stems from the original design, doesn't it? Prioritizing that decentralized security through very broad agreement, which just inherently limits throughput.
Mhm.
And as soon as these things got popular, the limitations really started to bite.
Yeah.
High latency, high costs, it kind of undermines the whole point for a lot of use cases.
So how do we fix it? How do we open up that bottleneck? There seem to be broadly two ways people are attacking this.
You've got layer one solutions, that's um, fundamental changes to the blockchain itself. Think Ethereum moving to proof of stake, big core changes.
Major open heart surgery on the network.
Right. And then there's layer two. These are more like clever additions built on top of the existing blockchain. No radical changes underneath.
Exactly. And that's where we're going today, isn't it? We're diving into one specific type of layer two, state channels.
Yes, state channels. So what's the big idea with them?
Well, the really neat thing about state channels is they try to let people execute contracts and interact off the main blockchain, but still in a trustless way.
Okay, off-chain. So avoiding the main traffic jam.
Precisely. You sidestep the high costs, the slow speeds, maybe even some of the privacy issues you get when everything's on a public ledger.
Interesting. You hear a lot about layer two now, but it feels like state channels specifically sometimes get lumped in with payment channels. Are they studied much on their own?
It's a good point. They're often discussed together, and maybe dedicated deep analyses just on state channels are a bit less common. But the core concept is powerful.
So give us the elevator pitch. How does a state channel actually work?
Okay, imagine two or more people want to do a bunch of transactions together. First, they kind of put some collateral down, they lock some assets on the main blockchain, like a deposit.
A digital handshake sealed on-chain. Got it.
Yeah, exactly. Once that's set, they can basically interact directly off-chain. They update the state of whatever application they're using. Could be a game, could be anything just between themselves.
Privately.
Privately, quickly, cheaply. They only need to interact with the main blockchain again right at the end to settle up based on the final state, or if something goes wrong, if there's a dispute.
Ah, the dispute resolution. So it really takes a load off the main chain for most of the interaction.
That's the promise.
Yeah.
A huge reduction in on-chain transactions.
Yeah.
So typically you see three main phases. First, opening the channel.
The funding part.
Right. You put funds into a smart contract on-chain, usually,
Mhm.
and you agree on and sign the starting state of your application.
Okay, locked and loaded. Then what?
Then comes the off-chain part. This is where the magic happens. Users just send messages back and forth, updating their shared state.
Like playing chess by mail, but instant and digital.
Sort of. And crucially, these state updates are signed cryptographically. They usually include things like a nonce, just a counter, to keep things in order, the state before, the state after, and what action triggered the change.
So everyone has a verifiable trail of what happened off-chain.
Exactly. Both parties, or all parties in a multi-party channel, hold these signed updates. It's proof of the agreed-upon state at any point in time. In simple two-party cases, maybe only one person signs each step, but often everyone signs the latest state.
Okay, they're maintaining their own little private agreed-upon ledger. Then eventually they have to close it out. How does that work?
Well, the ideal way, the optimistic case, is everyone agrees on the final state. One person submits this final, signed state update to that special smart contract on the main chain.
The one holding the initial deposit.
That's the one. It's not just a vault, though. It's also the umpire. Like you said earlier, it contains the rules, the logic to understand the application's state transitions.
Right. So it can judge if a state update is valid if there's a fight.
Precisely. So the final state gets submitted. Then, typically, there's a challenge period, a window of time.
For anyone else in the channel to object.
Yeah, if someone thinks, hey, that's not the latest state, or that state is invalid, they can challenge it during this window by submitting their own proof, usually a later signed state update.
And if no one challenges?
If the clock runs out with no valid challenge, the smart contract says, okay, this state is final, and it releases the locked funds according to that state. Everyone gets what they're owed.
It's elegant, trust minimized, fast off-chain, but with the blockchain as the ultimate safety net.
That's the goal. And it all hinges on a couple of key things. Trustlessness. You need to know your funds are safe, even if others misbehave. And finality. That off-chain state, once agreed or settled on-chain, needs to be as solid as any other blockchain transaction.
And the big benefit, again, is just fewer transactions hitting the main chain, right? Boosting capacity.
Absolutely.
Yeah.
But it does rely heavily on the underlying blockchain being live. You need to be confident you can get a transaction through to the main chain if you need to, especially to challenge something unfair or close the channel. The main chain is your trusted arbitrator.
Okay. So that's the general idea. But you mentioned there's quite a variety in how people have actually built these.
Oh, definitely. Researchers and developers have come up with lots of different takes. Take sprites, for instance.
Sprites, what's their angle?
Sprites really focused on the dispute handling. They conceptualized the channel state as this sort of replicated state machine. Everyone involved keeps an identical copy of the latest valid state.
Okay, synchronized states. How does that help with disputes?
It means if a dispute arises, the goal is to ensure the most recent valid state that everyone agrees on can be finalized on-chain. They use a round-based system.
Round-based?
Yeah, participants exchange signed messages confirming the state for each round. If someone sends an invalid message or just stops responding.
The unresponsiveness problem.
Right. That can trigger a dispute. An honest party can present the last valid round's signed state. Then there's a process, ideally off-chain first, where others can either validate that round or provide proof of a later correct round.
So trying to sort it out amongst themselves before bothering the blockchain?
Exactly. That's a key insight from sprites to try to resolve disputes off-chain if possible. Only if that fails does someone escalate it to the main chain smart contract, which then uses the latest proven state to finalize everything.
Clever. Trying to keep the umpire out of it unless absolutely necessary. What about Perron? I think you mentioned virtual channels.
Yes. Perron's big innovation was virtual payment channels initially. This is really cool. Imagine Alice has a channel with Bob, and Bob has a channel with Carol.
Okay, ABBC.
Perron lets Alice pay Carol through Bob, potentially without needing any extra on-chain transactions for that specific payment path, and without Bob needing to be actively involved in every single transfer.
Whoa. How does that work? Does Gob just act as a passive pipe?
Sort of. It uses intermediaries, but minimizes their active role and the need for direct on-chain interaction for every hop. It increases privacy and significantly cuts down blockchain load for these multi-hop payments.
And the underlying tech for that is?
And it's based on their custom state channel design called a multi-channel. This multi-channel framework supports not just these virtual payment channels, but also
update mechanism too.
Yeah, and Perron's multi-channels updates aren't necessarily all or nothing. Participants can choose to accept only specific parts of a proposed state update. This was designed to handle lots of small parallel contract instances, they call them nano contracts, within the main channel, without letting anyone overcommit funds.
Interesting granularity. Okay, moving on. There's Force Move. What problem were they focused on?
Force Move really zeroed in on that participant inactivity issue. Someone just stops playing their turn in a game or ghosts the channel. That could lock up everyone's funds indefinitely.
Yeah, that sounds incredibly frustrating.
Definitely. Force Move targets turn-based applications like games and designs the protocol so that all the information needed to resolve a dispute, including proving inactivity, is embedded directly within the application's state itself.
So you don't need external proofs or complex timers. The state tells the story.
That's the idea. If it's your turn and you don't make a valid move within a certain implicit time frame based on the state progression, the other party can use the current state to force the application forward or resolve the dispute on-chain. Keeps things moving.
Neat. Okay, then counterfactual. Sounds more theoretical.
It lays out some important theoretical groundwork and criteria for what makes a good state channel. They talk about a safety criterion, your funds are safe, a finality criterion, the end state is valid, and things like responsiveness and off-chain desideratum, basically, encouraging good off-chain behavior.
So setting the benchmarks, what does it need to achieve this ideal state?
Well, like many designs, it assumes the blockchain is live, all participants are available, there aren't weird external reasons for people to cheat, and crucially, the application code itself is bug-free.
The classic assuming perfect code clause. Big one.
For the on-chain part, they suggest using a multi-signature wallet to hold the channel funds. They argue this improves privacy and makes it easier to upgrade the channel contract later. And it was designed with Ethereum very much in mind.
The multi-sig part. Any trade-offs there? Does it introduce different trust assumptions?
Potentially, you're relying on the multi-sig contract logic being sound, and managing keys becomes even more critical. But it does offer that flexibility and potentially better privacy than simpler deposit contracts.
Right. Now, C-channels aim for something different, being blockchain agnostic.
Exactly. They saw that lots of different blockchains could run smart contracts and thought, why tie a state channel design to just one?
Makes sense. How do they bridge different chains?
They use a couple of key components. One is an off-chain address translator, basically a directory that maps abstract channel concepts to specific functions on different blockchains. The other is an on-chain registry using hash time locks, or HTLCs.
Ah, HTLC is often used in atomic swaps.
Precisely. They use that registry to enable atomic interactions between channels, potentially even channels running on different underlying blockchains. So a transaction might only fully complete if actions happen correctly in channels on both chain A and chain B.
Wow, okay, that's ambitious. Cross-chain state channels.
Very. Though it's fair to say the security analysis published for C channels seem mostly focused on the payment channel aspects. The full implications for general complex state channels and disputes across chains may be less explored formally.
Understood. Then there are state assertion channels. What's the assertion part about?
This tackles a fairness issue in disputes. Imagine someone just goes silent or submits a clearly wrong state. Why should the honest party have to pay the gas fees to initiate the on-chain dispute process?
Yeah, good point. You're being penalized for their bad behavior.
Right. So state assertion channels propose an alternative. If someone's unresponsive, you can issue a challenge. The silent party then has a window to respond with just a state assertion, basically a hash, a compact fingerprint of their claimed state.
Okay, just the hash, not the full state.
Right. The challenger then looks at this hash. If they think it represents a valid later state, they can provide the next state assertion. If they think the hash is wrong, then they submit the full state data to the smart contract to prove the assertion was invalid.
And if it was invalid?
The challenger gets the other party's stake deposit as compensation for the trouble. It discourages submitting bogus assertions or going silent.
Interesting. Shifting the cost burden if someone's clearly stalling or cheating. Now, Kitsune sounds like it tries to bring a lot of ideas together.
Yeah, Kitsune is often described as sort of a greatest hits compilation. It aims to support end-party channels for pretty much any application, drawing inspiration from Sprites, Perun, and others.
So trying to be a general framework.
Exactly. They provide an application contract template to make it easier for developers. Participants agree to move an app into a channel, locking the original on-chain contract. A new state contract is made, defining who's in and the dispute rules. Off-chain, any state update needs everyone's signature.
And closing, smooth or messy.
Both are possible. If everyone signs off on a final state, it closes cleanly. If there's disagreement, a dispute is triggered, which in Kitsune typically involves proving the latest agreed state on-chain.
They tested it with Battleship, apparently. What did they find?
Their analysis suggested it's best for applications that aren't super dependent on everyone being online constantly, things without strong liveness requirements. But they also noted that if participants are generally uncooperative, the overhead and potential dispute costs could make it quite expensive.
And disputes tend to just end the channel.
Often, yes. A dispute in Kitsune tends to lead to closing the channel and falling back to whatever the last proven state implies for on-chain settlement, rather than having mechanisms to necessarily resolve the dispute and continue the channel off-chain.
Okay. Switching gears a bit, Hydra seems very focused on Bitcoin, right?
Yeah.
And UTXOs.
That's right. Hydra is designed specifically for Cardano's extended UTXO model, which shares similarities with Bitcoin's UTXO approach. It builds on isomorphic state channels.
Isomorphic, meaning?
Meaning the kind of things you can do and the way state works off-chain in the channel directly mirrors what's possible on the main chain using that UTXO logic.
Okay, so it fits naturally with the underlying chains model.
Yes. And Hydra adds features like committing new UTXOs into the channel or taking them out, all off-chain. And they envision an optimistic close that might not even need a contestation period, relying on the UTXO structure for safety.
So really pushing the boundaries of minimizing on-chain interaction within that UTXO context.
That's the aim. Now, a different kind of problem. What if you just can't be online 24/7 to watch your channels?
Yeah, that seems like a practical issue for many people.
That's where PISA comes in, proposing arbitration outsourcing
Outsourcing to whom?
to third-party custodians or watchtowers. You basically pay a service to monitor your channels for you while you're offline. They hold onto receipts as proof you hired them.
Like hiring a security guard for your channel.
Pretty much. If someone tries to cheat while you're offline, maybe submit an old state, the watchtower is supposed to step in and challenge it on your behalf.
Sounds useful. Any catches?
Well, you have to anticipate needing to be offline and hire them in advance. It doesn't help if your internet just suddenly cuts out. And the original peace concept mainly focused on protecting against one specific type of attack, the execution fork attack. It might not cover every possible dispute scenario. Plus, you're introducing trust in the watchtower service itself.
Right, another layer of trust or at least accountability. Brick also tackles this online presence issue, but differently, using a committee.
Yes, BRIC's approach is to remove the reliance on fixed time windows for disputes, which are tricky on blockchains. Instead of just the channel participants being involved in disputes, they propose involving a committee.
A dispute resolution committee.
Kind of. These committee members ensure the dispute process can move forward, even if some participants are offline. It gets rid of the need for everyone to be perfectly synchronized or for the blockchain to measure time accurately, which is hard.
But committees usually need paying.
That's the potential downside, yeah.
Yeah.
You'd likely need to incentivize these committee members somehow, adding a cost to the system.
Okay, so lots of specific designs. Was there work trying to formalize the whole concept of state channel networks?
Yes, definitely. Some research focused specifically on providing a rigorous definition and security model for networks of channels, which was arguably missing. They also designed a way to build virtual channels on top of these fundamental ledger channels, the ones directly funded on-chain.
Right, like Perron's virtual channels, but maybe more formalized.
Potentially, yes. The idea is you could have intermediaries within the Layer 2 network helping to route state updates or even resolve disputes for virtual channels connecting participants who don't share a direct ledger channel.
So the intermediary acts like a hub.
In a way, optimistically, they're just involved passively in setup and closing. But if there's a dispute in the virtual channel, resolution might involve interactions on the ledger channels connecting each participant to the intermediary.
Does that slow things down?
It could, compared to a direct dispute. The intermediary also needs to lock up collateral for every virtual channel they facilitate and be available, so they likely charge fees. And the initial design focused only on two-party channels.
But that got extended later. Multi-party virtual state channels.
Yes, same group extended it. They showed how you could layer multi-party virtual channels on a network of underlying two-party ledger channels, essentially connecting everyone who needs to be connected. They also improved the dispute process to make its complexity independent of how many intermediaries are involved.
Still requires good communication, though.
Yes, that extension generally assumes the network communication is synchronous, which isn't always realistic.
We've also seen blockchains like Eternity build state channels right into the core protocol, haven't we?
That's right. Eternity took the approach of integrating state channels as a fundamental scaling mechanism. The idea is that only the opening and the final closing state, or a dispute outcome, actually get recorded on the main chain.
So the blockchain is aware of channels as a native feature.
Exactly. You still need an initial on-chain transaction to open and fund it, signing the initial state. The application logic resides in a state machine accessible by the channel. Updates happen via signed actions passed between participants, checked by the state machine, and closing is another signed action sent to the chain.
And people have built channels for specific use cases, too, like gambling, game channels.
Yep. Game channels targeted the gambling industry, focusing mainly on two-player channels, possibly with a dealer entity involved. Game state progresses in rounds, players send actions to the dealer, dealer responds. As long as everyone plays fair, it stays off-chain.
But does it always stay off-chain during play?
That's a key point. Some implementations describe still involved an on-chain transaction for each state update, which kind of defeats the main purpose of reducing on-chain load. They did, however, define clear protocols for different end scenarios: normal closing, running out of funds, timeouts, or catching cheaters.
Okay. And finally, CryptoPoly. Trying to run Monopoly on the blockchain. Seriously.
Yeah. It was a proof of concept, really. To demonstrate that even complex, turn-based games like Monopoly could potentially run efficiently and cost-effectively using Ethereum state channels.
How did they handle the tricky bits, like disputes or random dice rolls?
They adapted the dispute mechanism from force move, which makes sense for turn-based games. And for randomness, like dice rolls, they borrowed techniques from another concept called fate channels, which deals with generating verifiable randomness within channels.
Fascinating. So looking across this whole landscape, sprites, Perun, force move, all the way to CryptoPoly, what are the big takeaways from all this research?
Well, first, it's good to see a mix of players, academia, industry, sometimes working together. That cross-pollination is healthy.
Yeah.
Generally, the technical work seems solid. Most papers or projects give you technical details, sometimes even code you can look at.
But maybe the security analysis isn't always as rigorous.
That varies. Academic papers tend to have more formal proofs and security definitions. Industry projects, sometimes less so, or the analysis might be narrower, like we saw with C channels focusing on payments.
Okay. And if we compare them directly, what are the common hurdles or requirements and what cool features pop up?
Well, a lot of designs still impose restrictions. Things like it has to be turn-based, or you need to know exactly who all the participants are up front and they can't change, or everyone needs to stay connected constantly. Those are pretty big limitations for broad use.
Right. But on the flip side, what features do they enable?
You see designs supporting n-party channels, not just two people. Those virtual channels are a powerful idea. Some allow for parallel execution of things within a channel, and compatibility with existing smart contracts varies too.
And what about the actual on-chain footprint? Is the goal always zero transactions during the active phase?
That's definitely the ideal for the optimistic path. No on-chain interaction while things are running smoothly off-chain. But the number of on-chain transactions needed for opening, closing, and especially dispute handling can vary quite a bit between designs and between ledger channels and virtual channels.
So it feels like state channels are really potent for certain things, but maybe the stars need to align perfectly.
That's a fair assessment currently.
Hmm.
The number of requirements, predefined participants, turn-based flow, connectivity means the scope of applications where they're a perfect fit is still somewhat narrow.
Which limits their overall impact on blockchain scaling for now.
Exactly. A big area for future work is relaxing those constraints. Can we have channels with dynamic participants? Can we handle more complex, non-turn-based interactions smoothly? The connectivity issue is being tackled by things like Brick and Pisa, but managing time reliably is still a general challenge for blockchains.
Okay, let's zoom out again. How do state channels fit into the broader Layer 2 landscape? We hear constantly about Rollups Optimistic and ZK. Where do state channels sit compared to them?
It's a really important distinction. Optimistic rollups process transactions off-chain, but post-compress data back to Layer 1. They rely on a challenge period where anyone can submit a fraud proof if they see something wrong.
Okay. And ZK rollups.
ZK rollups also compute off-chain, but instead of fraud proofs, they generate cryptographic validity proofs, ZK snarks, or starks, that mathematically prove the off-chain computation was done correctly. They post these proofs to Layer 1.
So both rollups are about processing more transactions off-chain, but still putting data or proofs on-chain. How is that different from state channels?
State channels are fundamentally trying to minimize on-chain interaction altogether. The ideal is just two transactions, open and close. Everything else stays off-chain between the participants unless there's a dispute. Rollups increase throughput capacity. State channels aim to use the existing capacity much more efficiently for specific interaction patterns.
Got it. Different philosophies. And we've seen a lot of activity in Layer 2 recently, especially after things like the Denkin upgrade on Ethereum, right?
Absolutely. Denkin introduced blobs, significantly lowering the cost for rollups to post their data to Layer 1. That stirred more activity on platforms like Arbitrum, Optimism, Base, Starknet, ZK Sync, many using rollup tech, though some also incorporate state channel concepts or other approaches like Plasma or Sidechains.
But they all share that core goal: scale the blockchain by moving stuff off the mainnet.
Right. Increase transactions per second, lower fees, but still inherit the security of the underlying Layer 1.
Okay. And just briefly, any recent market trends worth noting in this context? What was happening towards the end of 2024?
Well, a few things stood out. We saw an uptick in the active Bitcoin supply, potentially driven by long-term holders taking some profits as prices approach, say, the $100K mark, suggests some coins were changing hands.
Interesting. What else?
The derivatives market for Bitcoin got pretty hot, high open interest in futures, high funding rates for perpetual swaps. That usually signals increased leverage and maybe a higher risk appetite in the market. And stablecoin supply saw massive growth, climbing close to $200 billion. That reflects a huge demand for stable on-chain assets, likely for trading, settlements, DeFi, you name it.
So a pretty active and evolving market. Against that backdrop, and with rollups getting so much traction, Are state channels still relevant? Do they have a future?
I definitely think so.
Yeah.
Because they solve a different aspect of the problem. While rollups boost the total processing capacity, state channels are about making the absolute most efficient use of any given capacity for interactions between a defined set of participants. They uniquely minimize the load on the consensus layer.
So they're not really competitors to rollups, maybe more complementary.
Exactly. You could even imagine scenarios where state channels run on top of a rollup. Combining the throughput increase of rollups with the hyper-efficiency of state channels for certain applications could be incredibly powerful. It's about using the right tool for the job.
So wrapping things up, it sounds like state channels are a really powerful tool in the scalability toolkit. They offer this unique way to get fast, cheap, private interactions off-chain, anchored by the security of the main blockchain.
That's the core value proposition, yes. And we've seen this incredible diversity in designs trying to tackle different challenges and use cases.
Right, from handling disputes gracefully to enabling virtual connections to dealing with offline participants.
And the research isn't standing still. People are actively working on those limitations we talked about, trying to make channels more flexible, less restrictive about participants or turn-taking.
It really paints a picture where the future of blockchain scaling isn't just one solution winning out. It's likely going to be a combination of layer 1 improvements and a diverse set of layer 2 solutions working together.
I think that's very likely.
And state channels, with their focus on ultimate on-chain efficiency for certain kinds of interactions, seem poised to play a really important part in that future fabric. It leaves you wondering, doesn't it? As these technologies mature, what kinds of applications, maybe beyond just payments or simple games, will really thrive by leveraging the specific advantages that only state channels can offer? Definitely something to keep an eye on. Thanks for breaking it all down today.
My pleasure. It's a fascinating space.